Hi, this video is going to be on condensing logarithmic expressions. What I want to remind you of, first of all, these are the properties of logarithms that we can use. The main ones that you use are the first three. So what we're looking for when we condense logarithmic expressions is, this is our typical process, is we're going to take any constants if we have them and convert them into a logarithm using the same base. Then we're going to bring any coefficients that are in front of the logs inside. That would be property number 3 for part B. We're going to write any fractional exponents after that using radicals, and for steps D we are going to combine logarithms using sum or difference rules. That would be the first two. The final answer, very important, is going to be single logarithm. So let's take a look at some examples. First problem, have 2 log p base 3p plus log base 3q. So we have this number here. This number needs to go inside as an exponent. That would become log base 3 of p squared plus log base 3q. Let me show you these properties here. This property, number 1 here, will allow you to combine a sum of 2 logarithms into a logarithm of a product. Now we rewrite that as log base 3 of p squared q, and it's done. The second example, right there, we have 1/2 right there that we're going to bring inside. I will strongly discourage you from using negative 1/2, as a lot of problems I've seen happening when students try to handle that as a negative. Just keep the minus there and handle that as a positive number. So we're going to get log base 2m minus log base 2m to the power 1/2. It tells us that fractional exponents need to be converted to radicals. This is square root. It's going to become log base 2m minus log base 2 square root of n. We have a difference. So for a difference, our property is that we convert that into a quotient here, right? And we are going to get log base 2 m over square root of n. Okay. Example 3. So we have 3 numbers here that we need to bring inside, each one of them. Remember, we're going to just doing positive 5. So we're going to get log base 5 of x squared plus log base 5 of y cubed minus log base 5 z to the 5th. These two have a plus. We are going to multiply the quantities. So it's log base 5 x squared y cubed. This has a minus. We are going to divide by that over z to the 5th. And that is our answer. So, next problem. We have log. I want to remind you, this would be base 10 if you don't see a log explicitly written. We do have these 2 numbers that need to be brought inside as exponents. So first we're going to rewrite that log h minus log t to the 4th plus log 64 to the power 1/3. 64 to the power 1/3 is actually a number that you can evaluate. This would be log h minus log t to the 4th plus, this is a cube root of 64, which is 4. So this is log 4. Now you have to be careful. You have a difference here, but you have this one's being added. So what I always recommend, do the ones with the plus first, because that's the product. And this one's going to be subtraction. That means we're going to get log of 4h over t to the 4th. Alright? Next examples. Alright, now we're getting into something a little bit lengthier. So let's take a look at this one. It doesn't really matter that we have x minus 3 here, it's still going to be handled the same way. So we're going to get log base 6 of x minus 3 to the 5th minus log base 6 x plus 2, nothing changes here, minus log base 6x squared. Now, let me point these out. There's a minus here. So both these quantities, since you're subtracting them, they're both going to be where you use division. And you're going to do log base 6. So this one goes on top. Over here we're going to put x plus 2 times x squared on the bottom. This is how it's going to be left. Example 6, we have ln, that's base e. Just want to remind you, it doesn't matter a whole lot here, but it's good to remember. So nothing really changes, you still use the same property. It's going to be ln m to the 5th minus ln n to the 3rd. Subtraction, we're going to be dividing ln m to the 5th over n to the 3rd. Both examples 7 and 8 have something that needs to be addressed. One of the steps, actually step A that I showed you in the beginning, tells you that if you have a constant, it needs to be converted to logarithm. And we have a number here, and we can't really do anything until that number is converted to a log. So let's think about this. We have to write 2 as a log with base 3. So this is basically an exponent for 3. 3 to the 2nd power is 9. Let me rewrite the whole thing first. Now I can go ahead and bring these numbers inside. We're getting log base 3 9 plus log base 3 a cubed minus log base 3 of b to the power of 5 halves. So power of 5 halves is going to be written as the square root of b to the 5th. So we're going to get log base 3 9 plus log base 3a cubed minus log base 3 of square root of b to the 5th. And now we can combine a sum here, you multiply, difference here, you divide. So it's going to be log base 3 of 9a cubed over square root of b to the 5th. And a similar thing is going to happen with number 8. You have that number 3 that you need to write using a logarithm. So this is base 10. So base 10, 10 to the 3rd power is going to be 1000. So that here is going to be that, log 1000. We are rewriting the rest of our terms. I don't know why I put another parenthesis there, it's okay. Just as long as I close that. So the 4 here will be brought inside as an exponent. So we're going to get log 1000 minus log h plus 1 plus log h minus 2 to the 4th power. And now I can combine them. Again, we have a difference here. We're going to be dividing by that, but we have a plus here. So these two you're going to multiply, and this you're going to divide by. This is going to give us log 1000 times h minus 2 to the 4th power all over h plus 1. Okay? Hope this helps.